Welcome back to Material Atomics. I'm Michael Shiloh.
I'm Anastasia.
Today I want to talk about Prout's law. Prout was an English chemist, William Prout, and Prout noticed that all of the atomic weights were essentially multiples of hydrogen, and so he hypothesized that the fundamental unit of matter is the hydrogen atom.
Which is to say that all atoms are made up of hydrogens. Would that be correct?
Yeah, all atoms are in some way combinations of hydrogens.
Which is crazy because that's not how we think about atoms.
Right, so you've probably learned in chemistry class or physics that atoms are made out of these particles, and we've gone over this over and over on this show, but it's a pretty dissatisfying explanation when you find out that a particle is essentially a measurement, or the instantaneous collapse of a wave function, or some other abstraction, right? It's very difficult to build a house out of ideas. You have to actually build it out of material bodies. And so Prout's idea that atoms were made out of more compact, smaller atoms is a really intriguing idea, and it was entertained pretty seriously for a while. There's a number of different chemists that worked off of this. Prout got himself in some trouble. He got canceled in his day for, I think, fabricating some data about some
no!
stuff. Yeah, it was sad. But whether or not this is true or not, I don't mean to put Prout on trial right now. I don't know the details of it.
By the way, I come down hard on the fact that people who make up data should be canceled. I think you don't get a seat at the table. If you're gonna lie, liars can't, they have no home.
This has nothing to do with Prout's data, is the thing. This is just an idea this guy
No,
named Prout
this is
had.
just a larger...
Maybe he was a really shitty experimentalist and he made up crazy data. That has nothing to do with this idea. His idea was a really good idea. Honestly, and this is what's really funny about digging into the history of science in general, is there are a lot of not so savory people who have had really good ideas.
There's something to that. There's something to that. We talk all the time about the difficulty of taking apart the art from the artist, right? Artist is a real dick, but the art is fantastic. And I think the same is said for science.
Yeah, it's horrible to wrestle with that too, because you want to have heroes in these people, but ultimately they're just human beings.
And so, okay, so the guy has this theory that all atoms are made up of hydrogen building blocks. And you want to talk about the neutron because it's a particular illustration of this principle. So walk us through that.
Yeah, I think that if we begin to apply our material atomics ideas about electricity and the shape of the atom based on the electron being its outer surface, which teaches us about spin 1/2, which we've illustrated several times in the last few conversations, we arrive at this idea that the appearance of electrical properties is really the first moment that we get a hydrogen for the first time. So let's go back to the neutron. The neutron by itself is said to exist only for a few minutes. And then it undergoes this process called β-Decay. And what's really interesting is that the product of β-Decay is an electron and a proton and a neutrino, which we'll antineutrino, which we'll talk about in a moment. But right away, you have the picture of the fundamental mass constituents of that decaying body, the neutron. And I'm not disputing that the neutron's a body. It seems to act very much like a body. The fundamental constituents can add up to a hydrogen. Now,
plus a little bit extra.
There's some extra energy there,
okay.
Right? And that to me makes sense because the process that turns a neutral hydrogen, i.e. what we're saying is a neutron, into an electrically interactive hydrogen, i.e. a hydrogen, as you would think about it, an ionized hydrogen.
Proton. Right, that's the term for
in
it.
chemistry they call them protons, which is really funny. But yeah, you have this electrically interacting ionized hydrogen all of a sudden. And that seems to appear from the neutron by a natural process of decay.
But only when it's outside the nucleus.
Right.
So basically it blebs off of the nucleus and it's free. Like in the experiments I was looking at the original papers from the 60s where they were doing this, and they were basically irradiating bismuth, which is the source of this neutron beam, and then they're passing it through a scintillation detector that is looking to see how many of these beta negative and beta positive particles come off of it in a given span of time.
And so what I'm saying is that this is illustrating what Prout was hypothesizing. It's showing that when the atom goes through this fission reaction, it does bleb off a piece of material. The architecture of the original atom is rearranged. It's becoming a new element, essentially, or an isotope. So its architecture is changing, which makes sense. And then this bleb of material goes through some sort of metamorphosis, whereby at the termination of that metamorphosis, there's a highly energetic reaction that happens where something must change about its architecture fundamentally. And the change that occurs is that it becomes electrically interactive. And because we have deduced, or at least we have modeled electricity as having meaning, as charge as having meaning, and the meaning of that word is the motion of the surface of the atom.
Or the shape of it.
Well, yeah, or the shape, right? Something is allowing it not only to have this particular motion, but it's able to interact with other atoms in a conductive fashion.
And in our model, conduction is friction. And so basically you go from having a frictionless surface to a surface with friction. And to me, based off of the way that I think about this stuff, that means that there is a rugose surface that develops that gives you the ability to grip.
Exactly, and this puts us into the realm of now starting to dream about the neutrino, the antineutrino that accompanies this. Because for me, what better frictional surface would there be than the filamentary structure, this radial architecture of these elastic projections, these extensions that are evident in the radial distribution function of the electron, these pieces that aren't talked about beyond the shell. There's pieces of the electron out there. And so the appearance of those is potentially helping us explain what the neutrino is, maybe, the antineutrino in this case.
Elaborate on that. I'm not totally following yet.
Well, the production of a functional frictional surface that can conduct from one atom to the next momentum, this particular rotatory momentum that we've highlighted as our model for electricity. What better way to have a surface go from smooth, like the neutron, that's not able to frictionally engage, to one that's able to Velcro onto the next atom in this particular way, than the appearance of these radial projections.
So then it starts, okay, you have a neutron inside the nucleus, and
I wouldn't necessarily say that. I mean, I understand it's written that way because for the standard conception of the atom, there's no other place for it to be, but I'm not saying that the neutron's like hiding out in the nucleus. I'm just saying it's a piece of material from the atom.
From the nucleus or no?
Just from the atom.
You don't think that it's from the nucleus?
No, I think the nucleus is just a particular contortion of the fiber of the atom. The electron, the proton, they're just different places of measuring the motion of that fiber. So when you lose a unit of that fiber, it only breaks off in these droplets that are approximately enough to make a new hydrogen from. When you lose that droplet, it comes from the fiber of the atom in general. It doesn't have to come from any particular region of the atom. It's all the neutron, the atom itself, the electron, the proton, it's all made out of the same fiber.
I'll give you that.
They're just different structures that are formed out of that.
So basically the interconnected model that we have for the atomic structure is that it's a radial filament organization. When you bleb a piece of material off of it, we're suggesting that it's neutral because it doesn't have those connections yet.
Maybe they're not mature, right? I mean, I can imagine as the surface blebs off, it's going to take some filaments with it, certainly. But maybe it doesn't have the motion necessary. Maybe that spin 1/2 motion hasn't appeared yet. Maybe there's other surface frictional features. I mean, I was earlier suggesting that maybe the filaments are appearing in that 15-minute interval, but to me, it's like I think it would probably take a lot of the filaments with it when it goes.
Yeah, because it's hard to imagine a condition it's hard to imagine a condition where it wouldn't have any of the filaments on it.
Mm-hmm.
So, because if it's a piece of material off of the atom, what I would imagine is that as it leaves the atom, those filamentary connections trail behind it as it flies away.
Mm-hmm.
And when the tensile strength of those filaments is broken, then the neutron has some amount of filaments remaining. Like it has the filaments that basically just lash out and grab hold of whatever's around it. And that's going to be a really energetic reaction, right? Because anytime that you have elasticity that breaks, it's a rupture, and that rupture contains within it more energy than you had potential energy.
Well, instead of like moving all this energy around, you're just snapping a lot of effort into the system. Like you're putting a lot of pressure on it suddenly. I mean, that's what's really fascinating about it, is that this seems to happen discretely. Like as the neutron decays, there is this like pow to the system, right?
What's interesting is that based off of that paper, which I, granted didn't like 100% understand, then it's the way that it breaks is not like there's a discrete measurement. It's it's a normal distribution. It's a normal distribution of decay products, and what that suggests is that it's this thing that's happening at various different energy levels depending on the state of the neutron as it's blebbed out from the atom.
Yeah, to me it seems like the neutron has all of the motion and material necessary to produce that electron measurement later. The question is, how is it bound up in the architecture of the neutron such that when it dissipates into the system at large, it behaves as if it's a hydrogen all of a sudden?
Well, it behaves as a really highly charged hydrogen, because this is not, the proton and the electron that come off are not regular in terms of their energy content. They're moving faster, they're behaving, they're really high vibration, high resonance, whatever you want to call it. And so that to me speaks of it being a really explosive process that's happening.
Yeah, I don't think they're more charged, but I know what you mean. They're more energetic, I think.
Well, they measure energy through charge.
Yeah, they measure it through like deflection and magnetic fields, and that's see how this gets into a mess, because fundamentally weight, mass is a weight concept, right? That's why you mentioned before we started filming about the idea of matter and the subatomic matter, and I'm like, I don't know if that's the right word, because the concept of mass and matter seems to only really make sense in terms of assemblies of atoms. And so when you talk about things like weight and mass, you get into dicey territory in the subatomic world, because they're not really participating in gravity, right? Gravity seems to be the word that mass is most appropriate towards. And instead, in these experiments, they take the equivalent deflection effort necessary to move a mass, right? But in a gravitational field, and they translate that into electricity. But that gets a little weird, because we're actually splitting hairs about where the electrical activity is first appearing in these systems as well.
Well, so perhaps we can save that for a later conversation, but it sounds like the basis of this is that you have atoms that are capable of blebbing off a neutral droplet, and that neutral droplet has some half-life, and after the half-life is passed, it is registered as the two components that make up a hydrogen, which suggests that what it actually was a hydrogen inside of the atom to begin with, or like some quantized chunk of the atom that can be made into a hydrogen when put into a new condition. Yeah.
I don't think that it's like the hydrogen's like hiding out in a little house somewhere inside of the atom.
No, it's just that it's the building blocks. It's when you put that
It's got all the material and all the motion necessary to make a hydrogen. Exactly.
And when you free it from the confines of the nucleus, then it's able to, when you free it from the confines of the atom, then it's able to behave as the hydrogen.
Yeah, I think that there's a good case to be made for that.
Very cool.
So yeah, maybe we can do it. Hopefully we'll do an animation. It's probably worth mentioning that we have been working with a friend who is a much more talented animator than we are. And so look forward to some pretty amazing animations that are in the pipeline. We have a new Atom to roll out here at some point. It's really exciting. So hopefully we can, of course, illustrate what we're talking about today down the road. But, you know, we're using these material atomics conversations to brainstorm, get everybody's input. It's a really tiny community right now, but we really want to just work it out in real time. And that's why we're doing this every week. So stay tuned and, well, every week when we can. We got a lot on the plate right now. Anyways, yeah, let us know your thoughts. If you're not already checking out the podcasts, get over to Demystify Sci and see what we've been busy with. And otherwise, we'll see you next week. I don't know what topic we're going to do, but we'll find something cool. There's a list about a mile long, so we'll start at the top.